This video is just to put some information out there with regards to a product that we're working on at the moment. It's an experimental potential product to help the calibrator fine-tune ignition timing automatically. So what is ITA? It's an experimental potential product which may or may not be feasible. Our research is ongoing, but at the moment it looks promising. If it does make it to production, it's going to be the first product of its kind that we know of anyway. Feel free to leave a comment below if you know of something else that does something similar. And what it will do, or what it needs, is a correction table in the ECU that controls the engine, and it will send a signal to that. It will use that correction table to fine-tune, optimize the ignition timing as the vehicle is driven. And the goal of the product is not to give a final answer on this is the correct ignition timing. The goal of this product is to assist the calibrator fine-tune ignition timing, i.e. after a data log is done, to give the calibrator an idea of which direction they should be going with the ignition timing at different parts of the map. So what data is sent to the engine ECU? Well, this part is very simple. It just sends one signal to the ECU, and in this case it's going to be the pink line. And this signal, in this case, for example, 2.8 at the point that it's highlighted here, will go to the ECU that you have controlling the engine, and that will either advance or retard ignition timing depending on how you set up the correction table. So how does ITA work? It uses inputs from a trusted knock sensor, a knock sensor that the calibrator trusts. It uses a load center, so the MAF or the map signal. It uses an RPM signal. It will also need an engine torque sensor. Now this is going to be basically the backbone of the product. The ITA is not going to be something that is using the knock sensor to find optimum timing. We want to find optimum torque. We're not going to release what we are using at this moment. We will do it if and when the product comes close to release. It's not going to be something ridiculously expensive, and it's not going to be something that's going to be hard to set up. But we want to keep that under wraps at the moment until the product, if and when the product is ready. So that's the four signals there: knock sensor, load sensor, RPM, and an engine torque sensor. It outputs a 0 to 5 volt signal to the engine ECU's correction table, as I covered in the previous slide. And that will give the calibrator an idea of which direction to go to, i.e. advance or retard the ignition timing at different points in the map. So real world demonstration. So the next few slides are going to be the data that we've got from 4 tests, so you can see what you will be getting from the ITA and how to integrate it into your engine's ECU. For the testing purposes, we're using an ECU Master DET3. It's a piggyback ECU. If you Google it, plenty of links out there. And we're using the DET3 to do the data logging and also to make the ignition timing changes on the engine. We are also using a knock detection system that it outputs a 0 to 5 volt signal when it detects knock. This is what the ITA will be designed to work with. And in these tests, we used a very small part of the ignition map from 2,250 RPM to 3,000 RPM, from low load to high load. We did the testing at minus 10 degrees timing, at 28 Celsius, 37% humidity, minus 3 degrees ignition timing from stock, 28 Celsius, 37% humidity, stock timing 20 Celsius, 84% humidity, and again with the stock timing 25 Celsius and 45%. So this is the first test with the minus 10 degrees from stock ignition timing. You can see here how the test was done. So this is the 3,000 RPM, 2,250 RPM, and then we've got the load along the bottom. It's on a normally aspirated engine. And after the data log, this is what we get this is what the DET3 software gives us. So 3,000 RPM here, 2250 here. In this specific example, the lower the voltage, the more advanced the ECU is adding. This is going to be an average number. This is not a specific number. The engine was knocking in this case, even at minus 10, and that will affect the averages. The purpose of the product is to give the calibrator an idea of the direction in which to go for the ignition timing. So we can see here for 3,000 RPM, 2625 RPM, that there looks to be room for ignition advance there. Come on to -3 degrees. This was done back to back with a -10 degrees, so it's 28 Celsius. So we can see the voltages are 1.9, 2, 2, 2.1, 1.96, 1.3, 1.8. Again, average numbers. And if we come down to the correction table, so like 1.9, 1.8, 2 volts, basically we're looking at, it's saying an extra degree of ignition timing is the direction that we can be looking at going. Then we come on to stock timing, and this was done on a different day. Early morning, it was 20 Celsius and humidity was way up at 85. This was stock ignition timing, i.e. 0 in the ignition tables. And you can see that generally everywhere we could advance ignition timing. I was the one that was driving the car, and it just didn't want to knock. If we compare like with like, so that 3000 to 2250, we're looking at like 1 volt, 1.9, 1.2, sort of 1 to 2 degrees extra ignition timing is available for the increased humidity. So that was stock ignition timing for first test, and this one was a bit closer to the first test with -10 and -3, 25, so a bit cooler and a bit higher humidity. And here generally we're pretty close to stock ignition timing. So a summary of those demos for the -10 degree test. I think it was clear that the ignition timing could be advanced. For the -3 degrees, we could see that there was probably scope there for an extra degree of timing. Then we come on to the run with the stock ignition time and high humidity. There was scope there for like a 1 to 2 degrees of extra timing. This one is hinting at -2 degrees from stock, and this one is going like 1 to 2 degrees more than stock. So we're looking at 3 to 4 degrees difference in ignition timing because of the temperature and the humidity. And then we come on to the stock ignition timing where the temperatures were a bit closer to the -3 and -10. There was scope for an extra degree of timing. But again, temperature slightly cooler, 10% higher humidity, it's not like for like. So the interpretation of the demos at this point with the testing that we've done, the concept of the test appears to work. From those other tests that we did, humidity and temperature seems to have a massive effect. And other observations, the stock ignition timing that the engine uses appears to be pretty well optimized. There doesn't appear to be a lot wrong with it. The next steps are going to be more testing. We're going to do it tighter on the maps. We're also going to be prioritizing doing the testing in the same conditions. I do more back-to-back testing at the same times of the day, so we're comparing like with like. And then once we've done that, we'll do another presentation like this. We'll publish the results of that testing, and I think at that point we're going to be able to know if this is a product that we're going to pursue or not. So with regards to these updates, if you want to keep up to date with what we're doing with this product and other products, you can subscribe to the MoviChip newsletter and subscribe to the YouTube channel. If you want a product like that can help you fine-tune your ignition timing, then if this product goes ahead, I think this is a product that will be helpful to you. So again, that's it for now. Look after yourselves, stay tuned, and I'll see you again in the next video.